Welcome back. As I pointed out in the last video, we're going to actually learn how to calculate pH and pOHs for strong acids and bases, so you can see how it's contrastingly different when we do pH and pOH calculations for weak acids and bases. So without further ado, as I said, we would still be using these equations, but how we're going to get the components that are part of these equations are the key. All right, so I want you to calculate the pH of the following. All right, first thing you want to do is look at what is given. Is the acid given first? What is given as an acid or a base? Well, if your thing contains hydrogen at the start, then it is an acid. But it is a strong acid or weak acid. Well, you have to remember the 6 acids. So this is a strong acid. So first you have to determine if you have an acid or base. Once you determine if you have an acid or a base, then you determine if it is strong acid or strong base or weak acid or weak base. Same deal here. This is one of the 6 strong acids. So this is a strong acid. And anything with a OH minus or OH is a base. And group 1, which is the column 1, and group 2, hydroxides or OHs are strong bases. I've said that when I introduced the idea of strong bases. So this right here, folks, is a strong base. And this is also a group 2. This is group 1 base, this is group 2 base, but nevertheless it is a base and it is a strong base. All right, so that's the first thing you're going to do. If you don't do this, you're just making the problem more difficult than it already is, because it is not difficult, and the only way it will become difficult is you make it difficult for yourself. All right, now what I have given here, once you make that decision, now we have strong acids and strong bases. The good news is, if it is strong acid, the problem is 1,000 times easier than weak acid and weak bases. All right, so we have a concentration here, so 0.1 molar. If it is a strong acid, then this H3O plus is 0.1. Now keep in mind, from now, anything inside a square bracket means concentration, okay? I'm not going to repeat this too many times because I have repeated it in the past, but make sure I'll say it just one last time. So if you determine it's a strong acid, and it is an acid, of course, then whatever the concentration given corresponds to H3O plus. Means to find pH, all you got to do is put it in the expression, so it's negative log of H3O plus, which would be so log of 0.1 is 1. So basically you put negative log of 0.1, which will be plus 1. Now, say if I give you this and ask you to find pOH, you still have to find pH because we are given acid. That's what I meant by statement 2. If you're given acid and you're asked to find pOH, first you got to find pH. Now we can find pOH, even though that's not part of the question. I can add because I'm making these videos, so I can definitely do that. So it's 14 minus 1 equals 13. This is what we wanted. This is extra. All right, extra material. All right, so again, this is tricky because there's something you got to accommodate here. Again, this is a strong acid, this is an acid, and this is a strong acid. So the H3O plus is not 0.1, but it's 0.1 by something else. Well, this is called a monoprotic acid. It's got 1 hydrogen, it's monoprotic. This is a diprotic, it's got 2 hydrogens. Now again, you cannot do this calculation this way at all if it is weak acid in the first place. These calculations are done this way only if it is strong acid or strong base. Pay attention to the acid. This is weak, so we left it as 0.1. If it is diprotic, you multiply by 2. If it is triprotic strong acid, which there is none, so you can be safe to assume that you will never see a triprotic strong acid because there is none. So 0.1 times 2 is 0.2, right? This is your H3O plus concentration, not 0.1. So if you put 0.1, you're going to get a choice, which will be one of the answer choices, but that is not, unfortunately, the right answer. So pH equals negative log of H3O plus, which is negative log of 0.2, which would be log of 0.2 is 0.698. Now, how you calculate the value on the calculator is exactly the same. It's not changed. Okay? So you found pH. Now pOH would be 14 minus of that. 14 minus answer equals 14 minus answer. 14. All right, whatever that number is. Okay, 14 minus 0.698 is 13.302. Okay. All right, so as I said, statement 2, if you're given an acid, you can only find pH first and then find pOH. That's easier. There are ways you can get pOH first, but that's beyond the scope of this class. Unless you want to make things difficult for you and go that route, please help yourself, be my guest. All right, so we have determined this is a base and a strong base. So what we know is OH minus concentration is 0.25. Again, this is not, don't say monoprotic because protic is only for acid. This is a 1 OH, right? So you can safely assume that OH minus is 0.25. As I said, it's OH minus, so we have to first find pOH, which would be log of 0.25 is 0.602, but that's not what the question is asking. The question is actually asking for pH. So pH equals 14 minus 0.602 equals 14 minus 0.602 is 13.398. That's your pH right there. So this is your pOH. As I said, you first find this, and then again, as with the other case, this is a strong base and it's a base, but we got 2 of the OHs, right? So the OH minus concentration is not simply just 0.25, it's 0.25 times 2. Now, as I keep repeating, you cannot do these calculations this way once you deemed it is a weak acid or weak base. Forget about this. You can't do it this way, all right? So it'll be 0.50. All right, so pOH would be, as I keep saying, you got to find first OH minus. If you have OH minus, you got to first find pOH and then you find pH. So it'll be negative log of 0.50. So log of 0.50 is 0.301. And pH would be 14 minus 0.301 is 13.7. All right, so I have explained every possible combination of how this will be asked. So if you know how those 4 problems have been worked out for you, then you know every possible way I can ask you this pH for the strong acid and the strong base, because there are only limited number of strong acids and strong base, as there is a plethora of weak acid and weak bases. So you can find yourself grabbing your breath, because this is mostly what I can test. I can change the formula a little bit, but because there's only limited number of strong acids and strong bases. All right, so I did this. So when we do weak acid, weak base concentration, and then pH and pOH, you yourself can go back between videos and see how contrasting they are. All right, so you do need to know this, and I have worked it out for you. All right, now stay tuned for weak acid and weak base calculations.